Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published just 10 days ago, which introduces a new method that achieves a state-of-the-art FID score of 6.67 on the Midjourney 30K benchmark, more than halving the error of the previous baseline. The paper is titled ARAG, Autoregressive Retrieval Augmentation for Image Generation. Alright, so the core idea here is to tackle a common problem in image generation, things like local distortions or inconsistencies. This paper introduces a technique called Autoregressive Retrieval Augmentation. Instead of looking at a whole reference image at the start, it dynamically retrieves small, relevant patches of images at each step. It uses the parts of the image it's already created to find the best visual snippets from a database to guide what comes next. This patch-level approach really helps reduce those distortions and improves object consistency, and as we'll see, the results are quite impressive. So this first figure really illustrates the key difference. On one hand, you have standard image generation, and then image-based retrieval, which pulls in whole reference images at the start. But the new method, Autoregressive Retrieval Augmentation, is much more dynamic. As it generates the image, it stops at each step to predict the next patch. It uses the part it just made as a query to find the most relevant tiny patch from a database, like a piece of a cat's eye or the texture of a basketball, and uses that to guide the very next step. This step-by-step retrieval process is what helps it build a much more coherent final image. Building on that idea, this figure shows the architecture for one of their two main approaches, called feature augmentation in decoding, or FAID. So what's happening is, as the model generates an image, it converts the existing patches into numerical representations called embeddings. It uses these embeddings to query a database for similar patches. The feature augmentation in decoding module then uses a convolutional layer, which helps blend these retrieved patches smoothly, and assigns each a compatibility score. This score determines how much influence that patch has on generating the very next piece of the image, ensuring a coherent result. Alright, so moving to the results. This table shows how these models perform on the general eval benchmark, which specifically tests how well they handle complex prompts, things like generating multiple objects or getting their positions right. The baseline model, Generative Pro, scores 0.71 overall. Now, when they add their new methods, the first, called Distribution Augmentation in Decoding, or DAD. That's a training-free method. It nudges the score up to 0.72. But the feature augmentation and decoding approach we just discussed really shines, boosting the overall score to 0.78, with big improvements in generating two objects and placing them correctly. This next table then evaluates performance on the Midjourney 30K benchmark, and the results here are really striking. It uses a few key metrics where lower scores are better, like FID, or Fréchet inception distance, which measures overall image realism, and CMMD, which checks how well the image follows the text prompt. So if you look at the Generative Pro model, it starts with an FID score of 14.33. But when they add their feature augmentation in decoding method, that score plummets to 6.67. This is a huge leap, more than halving the error. And those impressive numbers translate directly into what you can see. This figure provides a great visual comparison between a standard method called ImageRag and the new Autoregressive Retrieval Augmentation. You can see that the older ImageRag method tends to just copy the reference image and often fails to follow the prompt. For instance, when asked for a green couch and an orange umbrella, it just generates the couch. But the new method, it correctly combines both elements, showing how its dynamic, patch-by-patch approach creates a much more accurate and coherent final image. Okay, and this next set of images gives us another look at the qualitative results. The top row shows the baseline model, Generative Pro. So for the prompt about a camel next to a plush, round, red couch, you can see it gets the camel and a red couch, but the couch itself is pretty standard. The middle row, using distribution augmentation and decoding, makes a subtle improvement. But the bottom row, with feature augmentation and decoding, really delivers. It generates a couch that is very clearly plush and round, showing how this method excels at capturing specific, tricky details. So to wrap things up, What we've seen is that current image generation methods can often miss the mark on complex details. This paper introduces a really clever solution with its autoregressive retrieval augmentation. Instead of looking at a whole reference image just once, it dynamically pulls in small, relevant image patches as it builds the new picture. This patch-by-patch approach leads to massive gains in quality and accuracy, setting new state-of-the-art results. It's a powerful new way to make AI-generated images much more precise. Thanks for tuning in.